In this problem, we're told that the logistic growth function f of t equals 720 over the quantity 1 plus 8.0 e to the negative 0.13 t. And this function describes the population of a species of butterflies t months after they are introduced to a non-threatening habitat. In part A, we want to find the y-intercept of the function. So, let's try that. The y-intercept is the value where our independent variable, which is normally x, but in this case is t, when that's equal to 0. So we're just going to find f of 0. So we have 720 over 1 plus 8.0 e to the negative 0.13 times 0. So this gives me 720 over 1 plus 8.0, and negative 0.13 times 0 is just 0. So now we have e to the power of 0, and that is equal to 1 because anything to the 0 power is 1. So this gives me 720 over 1 plus 8.0 is just 8 times the 1 from the e to the 0 is still 8. So I have 720 over 9, and that goes in evenly, so I didn't even have to round. And I get 80 butterflies. Now in part B, it asks me to explain the meaning of the y-intercept in the context of the number of butterflies. So, the growth function describes the population after t months. So, the y-intercept is going to be that's a long pause. The y-intercept is the population of butterflies at the beginning, or when time is starting for this problem. So there's a few different ways you can word that, but anything in terms of that, it's the population of the butterflies. How many butterflies do we have when we are starting? So that's how you do that problem.